from here, it's going to be a messy equation, like we can see that already, right? So you have positive summation of moment about z-axis at a certain distance x is equal to 0. So the first P is going anti-clockwise, so it's equal to px, right? And then the B, right, the B at point B, you have going clockwise, so minus P plus by omega over 2 L minus 2A multiplied by distance x minus A, right? And then the third one is the omega x minus A is going anti-clockwise, plus by omega x minus A multiplied by x minus A divided by 2 plus by m as a function of x to 0. Okay.
Why don't we just add the areas together by sections for the bending moment?
We are forming equations, not adding the area under the shear force diagram. Does that make sense?
Yeah,
I know that by just adding, like, you get the area, like P times A, you get your magnitude, yes or no?
Yeah.
You only know at one point. But we are forming the equation where I can know at any point x what is our bending moment diagram, bending moment magnitude.
Okay.
Now, why? Okay, I know you have seen this topic before, but the later part where you don't see is this. Okay, why this is important? Because later on, so later on when you see the shear force, you get your what? Bending moment. Okay, so how does shear force relate to bending moment? You do integration.
Integral.
Yes. From moment, using elastic curve, right? You can get your what? Your slope, which you don't know yet.
I haven't gone past. I haven't done the angle of.
Yeah, so you don't know yet. So that's why I'm teaching you things that you don't see yet. That's why you asking me question. Why don't I easily take the area? And it's for that reason. That is why we are forming the equation. Then by forming the equation, you only can get the shear, the slope, and the deflection based on equation, not based on area. Are we clear?
Yeah.
Okay, so that's why I'm making you memorize Vm theta y, Vm theta y, Vm theta y for this reason. Okay, right. So that is a bit sidetrack. Okay, so that's where we are going further. Okay, I hope we are always going further. So now we have formed this equation. As you can see, it's pretty untidy. Okay, it's pretty untidy. So I'm just going to move along. I'm just going to expand this. So px, I'm going to do quickly. Okay. So minus by px minus by pa, right? So plus by omega over 2 L minus 2a multiplied by x, and then you will have minus omega a over 2 L minus 2a. So any one spot mistake, let me know. Okay, I think I'm good so far. Then you have plus by omega over 2 x squared minus 2ax plus by a squared. Okay, so plus by m as a function of x is equal to 0, right? So when we open up the bracket, we can get rid of these two, minus minus plus, so you have pa minus omega over 2 L minus 2a as a function of x. Okay, so minus minus plus omega a over 2 L minus 2a. Then the rest is plus by omega x squared over 2 minus 2a omega x, 2a omega x over 2. So you have so minus a omega x. Then you have plus by omega a squared over 2 plus by m as a function of x. Okay. Then we expand further. Okay, so PA minus by omega L over 2. So cancel x. I'm losing it again already. Plus by a omega x. Let me check. PA PLX over 2 minus, yeah, so plus by omega AL over 2 minus by omega A squared plus by omega x squared over 2 plus by a omega x, so minus. So the moral of the story is the day before the exam, make sure you sleep well. Okay. Right. So anything we can get rid of. There are some things that we can get rid of, right? So we know that we can get rid of these two terms, a omega x we can get rid. And then the omega a squared, we can do something about it. Okay, so we're going to write, okay, I'm going to write at the side. So PA still stay, right? Nothing to do. So omega Lx over 2, is there any omega Lx? So we still have minus omega Lx over 2. Okay, we cannot get rid of anything. Then omega Al over 2, we cannot do anything. Okay, so these things will stay. So omega A squared, we can do something, right? So minus omega A squared over 2. So this and this are taken. So plus by m as a function of x holding going to 0. Right? So now we were to, so 1, 2, 3, 4. 1, 2, 3, 4. I think I'm missing something. And I'm missing something somewhere.
You are missing WX.
Yeah. I was hungry. Thank you. So plus by omega x squared over 2 plus by m as a function of x is equal to 0. Okay, so we're going to tidy things up. I'm almost done. So from here, we know that we have m as a function of x will be equal to minus PA plus by omega Lx over 2 minus by omega AL over 2 plus by omega A squared over 2 minus by omega x squared over 2. Okay, so let me check. Bring it over. So minus flip. Correct. Okay, so finally we're going to take out omega over 2. Okay, so we will have minus x squared plus by Lx. All right, and then you have minus AL plus by A squared, okay, minus by PA. Right. So what you can see down here, if you look at this expression over here, this is a second order, right? Look at it. So this is a second order, right, polynomial equation. Okay. So the thing you were asked, hey Eugene, how do you know it's right again, right? So how do you know that this equation is right? To be frank, I don't know. I really don't know this equation is right. So I'm going to substitute. So like what I told you earlier, right? Like what? So we're going to substitute when x is equal to a, right? So if we go back to our graph over here, right? We go back to our graph down here. When x is equal to a, right, we should get a value of minus PA. If you don't get a value of minus PA, that's where something gone right, something gone really wrong. Okay, so from here, we substitute into A. So M, when the value is A, so this is equal to omega over 2. So you have minus A squared plus by AL minus by AL plus by A squared minus by PA. This whole thing dropped to be 0. So it's equal to minus PX. Minus PA. Right? So when you check, you have a more or less have a confidence whether your answer is right or wrong. Right? Okay. Now coming back to here now. So this is a polynomial, second order polynomial equation. Okay. Then I'm going to substitute. Okay. So we know second order, right? Sorry, we know that a second order and its negative sign, right? So the highest term is negative, right? It will be a sad face, right? When it's positive, you'll be a what? A happy face, okay? I mean, a happy face curve, and one is a sad face, okay? So if you go over here, we know that we are going to draw something sad face, okay? We are going to draw sad face. But the next thing that we have to ask ourselves, if we're going to draw, what will happen when it becomes L minus A? We know it's going to be a sad face, okay? We are aware that it's going to be sad. Sad face is going to be sad. Yeah, I'm miserable with the bloody lockdown though. But anyway, so we're going to substitute L minus A, see what will happen. So we're going to substitute when X, okay, we're going to substitute.
Doesn't it go to 0?
Let's substitute and then we see what will happen. Okay. So let's say now we substitute equal to minus A now. Okay. So I know what you mean. I think you're right. Okay. So let's try this. So now we have minus L minus A squared plus by L minus A, right? Minus AL plus by A squared, all right? Minus PA. So from now we don't know. Okay, from now we don't know. Okay, so we're gonna expand it. I also don't know. Okay, but I know that what you say makes sense. So minus L squared minus 2AL plus by A squared, right? Plus by L squared minus by AL minus by AL plus by A squared minus PA, right? So this is equal to omega over 2 minus L squared plus by 2AL minus by A squared plus by L squared minus by 2AL plus by A squared minus by PA, right? So this and this cancel. This and this cancel. This and this cancel. And you're right. It all equal to what? 0. Okay? I'm teaching now. So I want you all to be very comfortable. Some of you have a background knowledge. You know that it's equal to 0, fine. Okay? Some of you cannot visualize it. I'm going to take it. I also cannot visualize it. That's why I'm doing this, okay? Right, so from here, we know that the next point over here at L minus A, right, over here,